Since the dawn of time, humans have looked up at the stars and asked the same question: are we alone in the universe? NASA has been at the front lines of answering that question. Today, we'll explore their fascinating journey, filled with discoveries, mysteries, and the ongoing search for life beyond Earth. When NASA was founded in 1958, its primary goal was exploring space. But one question lingered above all others: are we alone? By the 1960s, the excitement of the space race wasn't just about rockets or astronauts. It was about what might be out there waiting to be discovered. Scientists inside NASA began to push for a serious, scientific search for life beyond Earth. This wasn't science fiction anymore, it was real research, backed by cutting-edge technology. In those early years, radio astronomy was booming. Giant dish antennas were being built to capture faint signals from the stars. Some NASA scientists asked, what if we use this technology to listen for alien civilizations? That idea may have sounded bold, even crazy to some, but it sparked the first programs to use radio telescopes in search of artificial signals from space. The dream of detecting a message from an advanced civilization was officially alive. But NASA wasn't just thinking about intelligent aliens, it was also thinking small. Very small. Microbial life. Could tiny organisms exist on nearby planets or moons? That thought became the foundation of what we now call astrobiology. By the mid-1960s, NASA had already started designing missions with one goal: to detect life, no matter how simple, anywhere in the solar system. At this point, the United States was investing heavily in space exploration, fueled by the competition with the Soviet Union. While much of NASA's attention was on landing a man on the moon, behind the scenes, other teams of scientists were planning for Mars and beyond. To them, planting a flag wasn't enough. Understanding whether we were alone in the cosmos was the bigger, deeper mission. So, in the 1960s, NASA's quest for aliens truly began, not with a spaceship landing on another planet, but with a vision. A vision to search systematically, using science, for life beyond Earth. This was the moment humanity's ancient question became more than philosophy. It became an experiment we could actually try to answer. In the 1970s, NASA took a bold step in the search for alien life, sending the Viking 1 and Viking 2 landers to Mars. Launched in 1975, they touched down on the Red Planet in 1976, making history as the first U.S. spacecraft to successfully land and operate on the Martian surface. These landers weren't just built to take pictures or measure rocks. They carried something far more exciting: experiments designed to detect life. For the first time in history, humanity had tools on another world, actively looking for signs of biology. The Viking landers conducted 4 groundbreaking biology tests, scooping up Martian soil and running experiments to see if microorganisms were living inside. One test, called the Labeled Release Experiment, gave scientists and the public a jolt of excitement. When Martian soil was mixed with nutrients, it released a burst of gas, exactly what Earth microbes would do if they were alive and feeding. Was this it? Had NASA just discovered alien life? Unfortunately, the other experiments painted a more complicated picture. While one test looked promising, the others didn't confirm it. Instead, they suggested that strange chemical reactions in Mars's soil, not life, might have caused the results. It was a crushing moment for many scientists, who desperately wanted a clear answer. NASA had come closer than ever before to detecting life, but the evidence slipped through their fingers. Still, Viking's legacy was monumental. It didn't just beam back biological data, it also gave us the first high-resolution images of the Martian surface. For the first time, Americans sitting at home could see Mars as a real place, not just a distant red dot in the sky. Mountains, valleys, and vast plains stretched across the landers' black and white photographs, sparking the imagination of millions. In the end, Viking didn't prove Mars was alive, but it didn't prove Mars was dead either. It left us with more questions than answers. That mystery would fuel NASA's obsession with Mars for decades to come, pushing scientists to build better rovers, sharper instruments, and bolder missions. Viking showed us one thing for certain: searching for life on another planet was possible, and the adventure had only just begun. For decades, many scientists believed life could only exist in conditions similar to Earth's surface: mild temperatures, plenty of sunlight, and liquid water. But in the 1980s and 1990s, a series of shocking discoveries changed that belief forever. Researchers began finding extremophiles, microorganisms that thrived in places once thought absolutely uninhabitable. Suddenly, the definition of where life could exist in the universe expanded in ways no one had imagined. One of the first surprises came from the ocean floor. In the late 1970s, deep-sea explorers discovered hydrothermal vents, cracks in the Earth's crust spewing boiling, mineral-rich water. To their amazement, entire ecosystems flourished there in complete darkness, powered not by sunlight, but by chemicals. Strange tube worms, crabs, and bacteria thrived in this hellish environment, where temperatures could soar above 700 degrees Fahrenheit. If life could survive here, could it also survive beneath the icy crust of Europa or in the methane seas of Titan? The surprises didn't stop there. Scientists found microbes in the driest deserts, in acidic hot springs, even locked inside Antarctic ice. Some extremophiles lived without oxygen. Others could survive extreme radiation that would kill humans instantly. Each new discovery was like a message from nature itself. Life is far tougher and more adaptable than we ever thought. For NASA, this was a game changer. Astrobiology, the study of life in the universe, suddenly had a new foundation. If microbes on Earth could adapt to such extreme conditions, then alien life didn't have to live in cozy, Earth-like environments. It might thrive in frozen moons, boiling planets, or even floating clouds of gas on giant worlds. The universe no longer looked barren. It looked full of possibilities. In many ways, extremophiles were the missing link in NASA's search for aliens. They showed that life isn't fragile, it's resilient. That realization reshaped mission planning, inspired new experiments, and kept hope alive that when we search other worlds, we're not chasing science fiction. We're chasing something that biology on Earth has already proven: where conditions allow, life finds a way. When NASA launched the Hubble Space Telescope in 1990, no one could have imagined just how much it would transform our view of the universe. Orbiting far above Earth's atmosphere, Hubble had a crystal-clear window to the cosmos, free from the blurring effects of air and weather. For the first time, humanity could see distant galaxies, nebulae, and stars in breathtaking detail. But Hubble's legacy wasn't just about pretty pictures. It gave scientists the tools to study worlds beyond our solar system in ways they never thought possible. In the 1990s, astronomers confirmed the first exoplanets, planets orbiting other stars. At first, they were giant, strange worlds nothing like Earth. But as detection methods improved, the list grew rapidly. NASA's Hubble helped confirm some of these alien worlds by analyzing starlight passing through their atmospheres. Imagine that, using a telescope floating above Earth to study the air of a planet hundreds of light years away. It felt like science fiction, but it was real. The discoveries didn't stop there. By the 2000s, NASA launched missions like Kepler and later TESS, which expanded the search into overdrive. Thousands of planets were suddenly detected, many of them sitting in the habitable zone, the sweet spot around a star where liquid water could exist. For the first time in history, scientists had evidence that Earth-like worlds weren't rare at all. They were everywhere. Each discovery was a reminder that our solar system might not be so unique after all. For everyday people, the thought was electrifying. It meant that when we look up at the night sky, we're not just seeing stars, we're seeing entire solar systems, each with the potential for worlds like our own. NASA's growing catalog of exoplanets gave the alien hunting community something new, not just, "Are we alone?" but, "Which of these planets might have neighbors we've never met?" Hubble and its successors shifted NASA's search for life into a new era. The question was no longer about whether planets exist. It became about which of those planets could host life. Suddenly, the search wasn't limited to Mars or Europa, it extended across the galaxy. For NASA and for humanity, the discovery of exoplanets was more than science. It was hope. Hope that among billions of stars, one of those worlds could finally reveal the answer we've been searching for. For life as we know it, water is the key ingredient. Without it, Earth's oceans, rivers, and even our own bodies wouldn't exist. That's why, in NASA's search for aliens, one guiding principle has always been follow the water. If you can find liquid water in the universe, you've found a place where life might have a chance. And over the past few decades, NASA has uncovered stunning evidence that water, past or present, exists far beyond Earth. Let's start with Mars. For centuries, people imagined canals and oceans on the red planet. While early telescopes gave misleading views, NASA missions eventually confirmed that Mars once had a much wetter past. Orbiters captured images of dry riverbeds, ancient deltas, and minerals that can only form in liquid water. Billions of years ago, Mars may have looked surprisingly Earth-like, with flowing rivers and maybe even a vast ocean covering its northern hemisphere. But that wasn't the end of the story. In recent years, rovers like Curiosity and Perseverance found even more clues. They discovered chemical fingerprints of water locked in Martian rocks, and signs that salty water might occasionally seep to the surface even today. While Mars is now cold and dry, these hints suggest the planet wasn't always so lifeless. If microbes ever lived there, water would have been their lifeline. Meanwhile, NASA turned its attention to the outer solar system, specifically, Jupiter's moon Europa. Covered in a thick shell of ice, Europa doesn't look like much at first glance. But data from the Galileo spacecraft in the 1990s revealed something shocking. Beneath that frozen crust lies a global ocean, containing more water than all of Earth's oceans combined. Later, the Hubble Space Telescope even spotted what appeared to be plumes of water vapor erupting from Europa's surface, like geysers blasting into space. Suddenly, Europa became one of the most exciting places in the universe to search for life. Beneath its ice, scientists believe the ocean could be in contact with a rocky seafloor, just like Earth's hydrothermal vents, the very places extremophiles thrive here at home. Imagine alien microbes swimming in the dark waters of a distant moon, surviving without sunlight, just as life does in Earth's deep oceans. That possibility turned Europa into a beacon of hope for NASA's quest, and set the stage for future missions designed to dive deeper into its mysteries. While NASA searched for signs of life in our solar system, another group of scientists looked outward, far beyond Mars or Europa. Instead of hunting for microbes, they were listening for messages from the stars. This effort, known as the Search for Extraterrestrial Intelligence (SETI), used powerful radio telescopes to scan the skies for signals that couldn't be explained by natural cosmic noise. The idea was simple but thrilling. If intelligent civilizations are out there, maybe they're trying to communicate. Then, in 1977, something extraordinary happened. Astronomer Jerry Emmon was working with the Big Ear radio telescope in Ohio when a sudden, 72-second burst of radio energy appeared. It was so strong, so unusual, that he circled it on the computer printout and wrote one word in the margin. Wow! This became known as the WOW signal. To this day, it remains one of the most mysterious signals ever detected from space. What made the WOW signal so special was that it came from the direction of the constellation Sagittarius, near a group of stars. It didn't match any known satellites, aircraft, or natural sources at the time. For many, it was the closest we'd ever come to receiving a cosmic hello? Was it proof that another civilization was out there? No one could say for sure, but the possibility electrified scientists and the public alike. Unfortunately, despite years of follow-up, the signal was never detected again. The Big Ear telescope continued scanning, and other observatories joined in, but the strange transmission vanished into history as a one-time event. Was it a glitch? A secret military transmission? Or could it have been the briefest whisper from another world, just out of reach? The mystery has never been solved. For NASA and SETI, the WOW signal was both inspiring and frustrating. It showed that the universe is filled with strange phenomena we don't yet understand, and it kept the dream alive that one day we might intercept a genuine alien message. Even now, new projects continue listening, scanning billions of radio frequencies, hoping to catch another wow, a signal that could finally confirm we are not alone. In 2012, millions of people around the world held their breath as NASA attempted one of the most daring landings ever attempted on Mars. The Curiosity rover was about the size of a car, packed with high-tech instruments, and it had to land using a never-before-tried sky crane system. Against all odds, it worked perfectly. When the rover's first pictures came back, showing Mars's rocky surface in stunning clarity, it felt like humanity had just touched down on an alien world. Curiosity's mission was bold, to find out whether Mars had ever been capable of supporting life. And almost immediately, it began uncovering clues. The rover found evidence of ancient riverbeds and minerals that formed in water. It even discovered that Mars once had conditions suitable for microbes, mild climates, liquid water, and essential chemical ingredients. This was the strongest evidence yet that Mars wasn't always the frozen desert we see today. One of Curiosity's most fascinating discoveries was organic molecules, the building blocks of life, locked inside Martian rocks. Even more intriguing, the rover detected seasonal spikes in methane gas in the atmosphere. On Earth, much of our methane is produced by living organisms. While it's possible the methane on Mars comes from non-living processes, the fact that it changes with the seasons made scientists wonder, could something underground still be alive and active? For the public, these findings reignited excitement. Mars was no longer just a dusty wasteland, it was a planet with a story, a past full of water, and maybe even hints of lingering activity. Suddenly, the dream of discovering alien microbes didn't feel so far-fetched. Curiosity wasn't just exploring rocks, it was rewriting humanity's understanding of a neighboring world. Curiosity's success also paved the way for bigger and better missions, like the Perseverance rover, which is now searching for signs of ancient life and even collecting samples to one day return to Earth. Thanks to Curiosity, NASA showed the world that the hunt for life is not a distant fantasy. It's happening right now, one scoop of Martian soil at a time. For decades, NASA's search for life focused mostly on the small stuff, microbes, water, and the chemical building blocks of biology. But in recent years, scientists began asking a bigger, bolder question: what if alien civilizations are advanced enough to leave behind signs of their technology? These potential fingerprints are called technosignatures, and they've opened an exciting new frontier in the search for extraterrestrial intelligence. So, what exactly is a technosignature? Think of it as anything in space that looks artificial, something nature couldn't easily create on its own. That might be unusual radio signals, strange patterns of light around a distant star, or even chemical pollution in an alien planet's atmosphere. Just as Earth's cities glow at night, and our industries release gases into the air, alien civilizations might leave behind detectable clues of their existence. NASA has begun to take this idea seriously. Scientists are now exploring ways to spot these technosignatures using existing telescopes and future missions. For example, a telescope might catch a repeating radio pulse that doesn't match any natural phenomenon, or it might detect gases like chlorofluorocarbons, CFCs, in an exoplanet's atmosphere. Compounds we know on Earth are produced only by industrial activity. If we ever saw something like that, it could be the smoking gun we've been waiting for. Of course, looking for technosignatures comes with challenges. The universe is a noisy place, full of natural signals that can trick us. Radio bursts, pulsars, and even interference from Earth can masquerade as alien transmissions. NASA's job is to carefully filter out the static and search for patterns that simply can't be explained by physics alone. The work is slow, meticulous, and sometimes frustrating, but the potential reward is monumental. What makes technosignature research so thrilling is the possibility of discovering not just alien microbes, but intelligent neighbors, beings capable of building technology, communicating, and perhaps even reaching out. For NASA, this shift represents a new level of ambition. We're no longer just searching for signs of life, we're daring to look for signs of civilizations. And that's a quest that could change humanity's place in the universe forever. In December 2021, after decades of planning, delays, and billions of dollars in investment, NASA launched the James Webb Space Telescope, JWST. Often called Hubble's successor, JWST wasn't just another space telescope. It was a time machine, a planet hunter, and a chemistry lab all rolled into one. With its massive golden mirror and cutting-edge instruments, JWST was designed to peer deeper into space and further back in time than any telescope before it. But one of its most exciting missions was directly tied to NASA's search for alien life, analyzing the atmospheres of exoplanets. By watching starlight filter through a planet's atmosphere, JWST can detect the chemical fingerprints of gases like carbon dioxide, methane, and even water vapor. These molecules are the same ones linked to life here on Earth, so spotting them elsewhere is like finding cosmic breadcrumbs that could lead us to something extraordinary. Already, JWST has delivered jaw-dropping results. It has studied the atmospheres of distant planets, detecting carbon dioxide for the first time on a world outside our solar system. In one case, it even picked up hints of methane and carbon-based molecules, the kinds of chemistry that make scientists sit up straight in their chairs. While none of these findings prove alien life, they show that JWST is doing exactly what it was built to do, pushing us closer to answers we've been chasing for generations. What makes JWST so powerful is its ability to look at planets we can't physically visit. We may not be able to send rovers to a world hundreds of light years away, but JWST can sniff out its atmosphere from afar and tell us whether it has the right conditions for life. This has transformed the search for aliens from theory into real, testable science. Every new exoplanet scanned is another chance to stumble on something that defies explanation. For many scientists, and everyday dreamers, the launch of JWST feels like we're living in a historic moment. For the first time, humanity has a tool that could realistically detect the signs of life on another world. If NASA does one day announce the discovery of alien biology, there's a good chance the first clues will come from JWST's golden eye, staring silently into the cosmos. As NASA looks ahead, the search for alien life feels closer than ever before. Future missions aren't just about exploration, they're about answers. Take Europa Clipper, launching in the mid-2020s, which will orbit Jupiter's icy moon to study its underground ocean. Or the Dragonfly mission to Saturn's moon Titan, where rivers of liquid methane carve through a landscape that eerily mirrors Earth. These missions aren't just sightseeing tours, they're designed with one bold goal: to find out if these alien oceans and atmospheres could host life. Meanwhile, the next generation of telescopes is already in development. NASA and its partners are planning observatories that could actually take pictures of Earth-like exoplanets and search for biosignatures in their skies. Imagine seeing a pale blue dot around another star, and finding oxygen, water vapor, or even signs of photosynthesis in its atmosphere. That's no longer science fiction. It's a future NASA scientists believe is within reach. But perhaps the most exciting part is the timeline. Many experts say that within our lifetime, we could finally detect proof of alien life, whether it's a microbe under Mars's surface, strange chemistry in Europa's oceans, or technosignatures from a distant civilization. For the first time in human history, the question, "Are we alone?" isn't just a mystery. It's a testable hypothesis. Of course, the answer might surprise us. We might find that life is rare, and Earth is unique. Or we might discover that the universe is teeming with biology, and we're just one of countless civilizations staring at the stars. Either way, the discovery will change how humanity sees itself forever. It won't just be science, it will be a moment of history, rewriting our place in the cosmos. And so, NASA's search continues, driven by curiosity, fueled by technology, and powered by humanity's oldest question. The truth is out there, waiting to be found. And whether the discovery comes tomorrow or decades from now, one thing is certain: the search for aliens is no longer just a dream, it's our destiny. So, what do you think? Are we on the edge of the greatest discovery in human history? Will NASA be the first to confirm alien life, or is the universe keeping its secrets hidden a little longer? One thing's for sure, the search isn't slowing down, and the next breakthrough could happen in our lifetime. If you believe we're close to finding life beyond Earth, hit that like button. And tell me in the comments, do you think we'll discover alien microbes on Mars, deep in Europa's ocean, or will the first signs come from a distant exoplanet? I'd love to hear your thoughts. And if you want to stay updated on NASA's journey and the mysteries of the cosmos, don't forget to subscribe, because the story of the universe is just getting started.